Hello everyone, my name is Nutifafa Adotey. I'm an assistant professor in the Department of Biosystems Engineering and Soil Sciences at the University of Tennessee Institute of Agriculture. I'm also University of Tennessee Institute of Agriculture New Soil and Nutrient Management Specialist. And this morning I'll be talking about corn and soybean soil fertility research work that's been done by myself as well as other UTIA soil scientists and specialists. And I also touched on some soil fertility resources that are available to optimize crop production in Tennessee. So I'll begin my talk this morning looking at University of Tennessee Extension publications on soil fertility. The first one will be Visual Symptoms, a handy tool in identifying nutrient deficiency in corn, cotton, and soybeans. This publication presents information on possible soil or nutrient deficiencies that you may likely see in the field. It has pictures of how some of these deficiency symptoms look like, as well as how to accurately collect tissue samples when you suspect any type of nutrient deficiency in your field. The middle extension publication talks about enhanced efficiency nitrogen fertilizer as a tool to control nitrogen loss in row crop production system. This publication presents information on the different nitrogen loss pathways that are available when you put out that precious fertilizer to your field and how you can minimize some of the losses. There are information on proven nitrogen stabilizers that are on the market that can reduce nitrogen loss as ammonia. And then the final publication, what does soil health mean for Tennessee farmers? It presents an overview of soil health. If you look at the bottom of all of these publications, you have a link. So if you have access to this PowerPoint presentation, you can simply click on this link and it's going to direct you to where these publications are located. Moving right along, the second resource I'd like to touch on is the Soil Fertility website. This was made possible by the Tennessee Corn Promotion Board. So this website is hosted at utcrops.com. So when you go to utcrops.com, if you look at the top section, you have UT Soil. So if you click on that, this is the home page of the Soil Fertility website. At any point when you're navigating through this website and you need to get back to the home page, simply click on UT Soil and Nutrient Management where the mouse cursor currently is, and it will take you back to the home page. So my goal here this morning is just to point out a few things that you can get from this website. The first one is that this website provides the University of Tennessee fertilizer recommendations, be it for agronomic crops, and we're talking about corn, cotton, soybeans, sunflower, tobacco. You can get all that good stuff right here. If you need information on pasture, what UT recommendations are for the different nutrients, as well as practices to optimize this nutrient, you can go to click on pasture. There's also fertilizer recommendations for commercial vegetables, commercial fruit and nut productions. If you're interested in home garden and you're not sure what the fertility recommendations are, you can simply click on that. Or you simply want to have a home garden, there's information on that as well. Or if you have home ornamentals. If you're interested in University of Tennessee publications, such as the ones that I mentioned in the previous slides, again, you simply go to Soil Fertility tab and it will guide you through how to access some of these extension publications. Also, if you need information on soil health, on cover crop, UT publications, blog articles, if you can go to there, you can go there and have access to all that information. Also, if you want to find out what if you want to find out the ongoing project, again, you can go in there and you have access to different soil fertility projects that's been done by myself in collaborations with other PIs as well. And then finally, there are links to other university websites, to crop commodity boards, to different associations and organizations and stakeholders that are involved in agriculture right here in Tennessee. So I would move now and I'll talk about research that we're doing. We did this past year and a couple of years ago looking at nitrogen management. This is very important considering the year that we find ourselves in, where fertilizer prices have more than doubled in certain cases. We want to make sure that growers have access to information that can help manage that nitrogen effectively. We know that for corn production, nitrogen is a big input, and we want to make sure that you get enough out of that nitrogen. So we know that you need nitrogen to make a very good crop, adequate amounts. We also know that nitrogen is a major investment in corn production. So if you look at the crop production budget, UT crop production budget that was released by Dr. Smith and other PIs, nitrogen applications represent about 20% of the total expenditure on unirrigated crop production system. Another challenge with nitrogen management is that it's a potential non-point source pollution. So we want to keep it from polluting the environment if there is. And the reason is that if you look at nitrogen compared to other nutrients, it's very susceptible through different nitrogen loss pathways. You can lose your nitrogen as ammonia, you can lose it to as nitrous oxide through denitrification, you can lose that nitrogen through leaching as well as surface runoff. Because of all of these different nitrogen loss pathways, nitrogen applications tends to have very low nitrogen use efficiency. So it's very important to manage that nitrogen by adopting or following best management practices. And we'll talk about one of such practice in a moment. So the 4R nutrient stewardship, it's one of the best management practices that are out there to minimize and optimize nutrient. In this presentation, I'll focus on just nitrogen. So we'll talk about how the 4R applies to nitrogen management in Tennessee. So the 4R is right source, right rate, right time, and right placement method. And we'll see how this looks like in Tennessee. So the first R is the right source. So urea and urea ammonium nitrate are commonly used nitrogen source by corn growers in Tennessee. Of course, there are other sources like anhydrous ammonia, ammonium sulfate, swine and poultry manure. One of the biggest drawbacks when it comes to urea-based fertilizers is that when they are surface applied and they are not incorporated into the soil, either by rainfall or tillage, within the first 3 days, they are susceptible to nitrogen loss as ammonia. Studies that have been done right here in Tennessee has shown that you could lose up to 28% of that nitrogen as ammonia within the first 6 days. The good news is that there are proven nitrogen stabilizers on the market that can minimize the risk of nitrogen loss as ammonia and maximize nitrogen fertilizer efficiency. The key word here is proven nitrogen stabilizers. There are stabilizers on the market, several of them, that may have active ingredients that can reduce ammonia loss by maybe at different concentrations and formulations. The key point is that whatever stabilizer product you choose to use, there has to be data to show that it is very effective at reducing ammonia loss. The second R will be the right place. So broadcast placement are commonly used placement method by corn growers in Tennessee. There are other methods like the wide drop, and the picture you see here is the wide drop method. And there's also dribbling in between the rows, as well as injecting that liquid UAN into the soil, which is pretty much the gold standard. Um, the challenge, again, the drawback with broadcast placement method is that if you surface supply and it's sitting out there without incorporation, it's susceptible to ammonia volatilization. Again, using a proven nitrogen stabilizer will minimize nitrogen loss as ammonia. So 2020, we did a trial looking at nitrogen sources and placement with or without a nitrogen stabilizer. So the nitrogen sources that we looked at, which is in the first column, is urea, ammonium nitrate, and urea ammonium nitrate. For urea and ammonium nitrate, we only looked at one placement method, which is simply broadcast. But for liquid UAN or UAN simply, we looked at broadcast, wide drop, dribble, and injected. So 4 different placement methods. And we looked at this combination with or without a nitrogen stabilizer. This study was done at the UT Research and Education Center located at Milan. And we split apply our nitrogen. We put 60 pounds of nitrogen at planting and side dress the remaining at the V6 growth stage. Let's look at some results from this work. So I want you to focus on the column 2, 3, and 4. So the column 2 shows us the different nitrogen sources. So the first 4 rows talks about urea, the fifth talks about ammonium nitrate, and the last 2 rows shows us urea ammonium nitrate. So the third column, if you see a dash there, that means that nitrogen source, they don't have any stabilizer. So let's look at the yields. Again, if you look at the first 2 rows, what you realize is that treating urea with Anvil increased yield by 13 bushel. Again, if you come down to the last 2 rows, treating urea ammonium nitrate with Anvil again also increased yield by about 15 bushel. Again, for all the treated urea or urea ammonium nitrate, there wasn't any significant difference in yield except for UAN treated with Anvil that had lower yield. Looking at the different placement method again, so you want to focus on column 1, 3, and 4. What we realize is that for column 3, when there's a dash, it means that nitrogen or broadcast placement method didn't have any stabilizer. Again, for broadcast and dribble, we saw that treating UAN with Anvil significantly increased yield. But for the wide drop and injected, addition of stabilizer did not provide any additive benefit when it comes to yield. Why did we see differences in yield? So it's partly due to ammonia volatilization. So in Tennessee, we also looked at ammonia volatilization. So we used the semi-closed chamber method where we evaluated the ammonia loss from surface applied urea and urea ammonium nitrate for 18 days. And I'll present the data in a second. So if you look at this graph, on the y-axis, you have cumulative ammonia loss, which is the percent of the side dress nitrogen. In this case, it was 120 pounds of nitrogen per acre. And then on the x-axis, it's time. This is days after nitrogen fertilizer application. So what you see here is that if you look at the clear, if you look at urea had the highest ammonia volatilization loss, which was 23%, followed by urea ammonium nitrate, which was about 10%, followed by ammonium nitrate, which was less than 1%. Again, if you look at this graph, almost 90% of that nitrogen loss from urea or urea ammonium nitrate occurred within the first 3 days of that fertilizer application. The third R is the right time. So pre-plant nitrogen fertilizer application in corn is not recommended in Tennessee. The reason is that corn plants take up very little nitrogen, less than 12% of the nitrogen uptake during the growing season until the V6 growth stage. So what happens is that if you have that nitrogen sitting on the soil surface and you have conditions that drive nitrogen losses like heavy rainfall, or you have issues with high humid temperature, what happens is that that nitrogen is susceptible to losses. The only exception where pre-plant nitrogen application is encouraged is when you're putting out anhydrous ammonia and you have with a properly calibrated equipment. So if you have to put out more than 120 pounds of nitrogen per acre, it's recommended that you split apply that nitrogen fertilizer. You add a third at planting and you side dress the remaining at the V6 growth stage. So we did studies again to look at the right timing last year. We conducted the studies at 2 locations, one in West Tennessee and one in Middle Tennessee. And at each of these locations, we had 3 different trials. The trials were just different on hybrid, and we looked at 2 different timings. We looked at single application versus split application. With a single application, we put all that nitrogen at planting, and with a split application, we put 60 pounds of nitrogen at planting and side dress the remaining between V4 and V6 growth stage at the various nitrogen rates that you see right here. All the urea that we used for this trial was treated with a nitrogen stabilizer. In this case, we used Amvol by Cook Agronomic Services, the same company that produced Agrotane. So we're going to look at a little bit of results. And what we see here is that the top picture, that is the plots, the 180 pounds per acre, pounds of nitrogen per acre plot that received all that at planting. And then the bottom picture was the split application. You can clearly see a little bit of differences. In terms of canopy, you see that split application has a dense canopy compared to the single application. You can see that there's more firing with a single application compared to the split application. Let's look at some data now. On the y-axis is your grain yield in bushel per acre, and on the x-axis is the nitrogen application rate in pounds per acre. What you realize is that you start seeing, let me mention this, that the orange bars represent the single application and the gray bar represents the split application. What you start noticing is that you see differences in yield at the 120 pounds of nitrogen per acre rate and beyond. Secondly, the split application of 180 pounds of nitrogen per acre had higher yield compared to single application of 240 pounds of nitrogen per acre. And then finally, you could see that single application of 180 pounds of nitrogen per acre was similar to single application of 300 pounds was similar. Let me take that again. Split application of 180 pounds of nitrogen per acre was similar had similar yields as the split application of 300 pounds of nitrogen per acre. Let's look at our final R, which is the rate, right rate. So nitrogen fertilizer recommendation from University of Tennessee is based on yield goal, and you can make modifications based on crop production history, and if you have other test related, we can make adjustments. Another tool that's available is the nitrogen rate calculator, available on uticrops.com, that provides economic optimum end rate as well as other related factors. So we did trials too in 2021, looking at different or trying to identify what the optimum nitrogen rate was for corn production in Tennessee. This study was done at 5 locations. We had 3 University of Tennessee Research and Education Centers, as well as 2 on-farm trials. So overall, it was 9 different trials. We used urea as our nitrogen source at different rates, ranging from 0 to 300 pounds of nitrogen per acre. So we apply the nitrogen that we use in this trial. For the plots that received nitrogen, we put 60 pounds of nitrogen at planting and then side dress the remaining. So for a rate like 240 pounds of nitrogen, we put 60 pounds of nitrogen at planting and side dress about 180 pounds of nitrogen per acre. Let's look at some pictures first. You could see differences in leaf color, plant height, as well as canopy cover with increasing nitrogen application rate. The picture you see at the top shows all the rates, but then if you the bottom left corner, it shows just 3 rates, and it actually gives you a better picture of the differences in color as well as height. The picture you see at the bottom right is your typical nitrogen deficiency symptoms, which we observe at the check plot, that V-shaped pattern or V-shaped chlorosis pattern that we see. So we looked at rate. So I'll talk about 2 different rates. We looked at economic optimum rate as well as economic optimum rate. So with your optimum rate, that is the rate at which you get the maximum yield, and the economic optimum rate factors in fertilizer prices as well as corn prices, and we'll look at that briefly. So based on our study, again, on the y-axis you have the grain yield, and then on the x-axis you have the nitrogen application rate. So what we realized is that the optimum rate was 195 pounds of nitrogen per acre, maximum rate, and that is equivalent, or that would give us a yield of about 225 bushels per acre. Again, when we looked at the economic optimum rate, 162 pounds of nitrogen per acre was the economic optimum rate, which will give us a yield of about 210 bushels per acre. So what is the take-home message? Okay, so when it comes to right source, the message is that add or treat urea-based fertilizer with a proven nitrogen stabilizer. It serves as an insurance. If you have rainfall right after application, it will incorporate that nitrogen and you don't have losses occurring. But if you have conditions that drive losses which cannot be predicted, then it provides a good insurance. So it's very important to treat that urea-based fertilizers. When it comes to right rates, based on the study of last year, based on last year's study, it's just 1 year. What we realize is that the optimum or the economic optimum end rate was about 162 pounds of nitrogen per acre. When it comes to timing, it's important to split apply that nitrogen when you are going to put out more than 120 pounds of nitrogen per acre. And then for right placement, again, surface broadcast urea or UAN that is treated with a proven nitrogen stabilizer is effective as injecting UAN. So moving right along, I'd like to also talk about a soybean research work that we conducted this past year. So plant tissue analysis is very important for two reasons. It helps us to monitor the nutritional status of the plant and also helps us to identify or diagnose any nutrient deficiency symptoms that may be in the field. So the interpretations of tissue analysis is based on sufficiency levels or sufficiency range. Most of the studies to identify these ranges were conducted several years ago, but we know that there's been improvement in genetics and newer varieties, soybean varieties have been introduced. So the question is, we want to make sure that the sufficiency ranges that we're using currently, they are fairly accurate and predictive enough. So to do that, we conducted trials. So we leveraged the CST trials by Ryan Blair, who manages the CST trial. We leveraged some of his trial plots, and we were able to reach out to different extension agents that manage this CST plot. So overall, we looked at 10 different varieties across 4 maturity groups. So we looked at Roundup Ready late group 3s, we looked at Roundup Ready early and late group 4s, and we looked at Enlist early and late group 4s, as well as Roundup Ready early group 5s. So what we did was the agent assisted us in collecting tissue samples at 3 different sampling times, between R1 and R2, between R3 and R4, and then at the R6 growth stage. And I'd like to present some of the data that we got from this research work. So on the y-axis, this will be your grain yield, and then on the x-axis, this is the soybean leaf N, leaf K, leaf P, or leaf B, which is your boron. And if you look at the right side of this slide, these are the different sufficiency ranges that we currently have. Any number that is below this ranges indicates efficiency level. So what we see here is that for all the nutrients except for nitrogen, they're within the sufficiency range. Nitrogen was slightly higher in most cases, which was a little bit surprising. But the reason why I have this graph here is that when we try to do a correlation between our grain yield and current leaf tissue concentration, we saw that there wasn't any correlation at all. So the take home is that the leaf nutrient concentrations at the R1 and the R and between R3 and R4 sampling times were within the current sufficiency ranges, with the exception of nitrogen, which was way higher than we expected. Again, we also realized that only soybean leaf P correlated positively with soybean grain yield, and it was only observed at between the R1 and R2 growth stages. Looking at all of this, we realized that there's a need to reevaluate the sufficiency ranges for leaf N, P, K, and micronutrient for the current yield levels using a replicated plot study. So I'd like to acknowledge the Tennessee Corn Promotion Board, the Tennessee Soybean Promotion Board, Ag Explore, Cook Agronomic Services, Southern Serve for funding some of the work that I presented today. Thank you, and you can reach out to me on my cell number or using my email address with any questions that you have. Okay, thank you for making time to listen to my talk.